Hey everyone, and welcome to the Deep Dive. Ready to get a little geeky with me today?
Always up for a good brain workout.
Awesome. Because today we're diving into the world of multi-objective optimization.
Ooh, that's a good one.
It might sound kind of intimidating, but it's actually way more relatable than you think. Imagine you're planning like the ultimate vacation.
Okay, I'm listening.
You want amazing experiences, delicious food, total relaxation, the whole 9 yards.
Great. Sounds amazing so far.
But you also have to think about your budget, how much time you can take off work.
Always the catch.
Exactly. And that's multi-objective optimization in action. You're juggling multiple goals, and they're often conflicting.
Yeah, you can't always have it all.
Nope. But you can try to find the best solution for you. And that's what we're going to explore today.
Sounds like a plan. Where do we start?
Well, we're going to be using a research paper as our guide today.
Okay, hit me with the title.
It's called Interactivized, Visual Interaction for Better Decisions with Interactive Multi-Objective Optimization.
Wow, that's a mouthful.
I know, right? It was published in IEEE Access back in 2021. Don't worry, we'll break it down so it's crystal clear, even if you've never optimized anything in your life.
I appreciate that. So before we go any further, can you give me like a super basic definition of multi-objective optimization?
For sure. Let's stick with that vacation example. You want it to be affordable, packed with adventure, and maybe even a little relaxing, right?
Yep, hitting all the key points.
Multi-objective optimization is kind of like having this tool that helps you explore all the possible vacation options, different destinations, activities, lengths of stay.
Okay, I'm seeing where you're going with this.
And then it shows you how each option scores on each of your goals.
So you can see the trade-offs, right?
Exactly. It's like having a superpowered travel agent who can show you not just one good option, but a whole range of possibilities. And they highlight the trade-offs between them.
I like the way you think. That's a really helpful analogy.
Thanks. So it's not just about finding one right answer.
More like finding the best compromise.
Exactly. And that's where this concept of Pareto optimal solutions comes in. Have you heard of those before?
I have. It's like the sweet spot where you can't improve one objective without sacrificing another.
You got it. So like if I wanted a longer vacation.
You might have to compromise on, say, the luxury level of your accommodation.
Right. It's all about finding that balance point that reflects your priorities. Now, there are different ways to approach these kinds of problems.
Right. There's like a priori methods where you decide your priorities up front. And then there's a posteriori methods where you kind of look at all the possibilities after the optimization is done.
And then there's the method that this research focuses on, the interactive approach.
Oh, tell me more about that. That sounds interesting.
Right. Imagine instead of just giving your travel agent a list of wishes,
Okay.
you're actually sitting down with them, like looking at maps and itineraries together.
Ooh, I like that. It's like a collaboration.
Exactly. And as you're exploring these different options, you might realize, hey, I'm willing to spend a bit more to stay closer to the beach. Or maybe I can shorten the trip to fit in that cooking class I've always wanted to take.
So you're adjusting your preferences as you learn more about what's actually possible. That makes a lot of sense.
It's not just about crunching numbers, you know?
It's about understanding the problem, exploring the trade-offs, and ultimately finding a solution that feels right for you.
You nailed it. But how do we actually tell the algorithm, or in this case, our imaginary travel agent, what we want?
That's where these things called reference points come in.
Reference points. Fill me in.
Yeah, they're basically your target values for each objective. Like, you might say, ideally, I'd like to spend no more than, say, $2,000, have at least 5 days of adventure activities, and 3 days just chilling by the pool.
Okay, so it's like giving the algorithm a starting point, a direction to explore, but it doesn't mean we're locked into those exact values, right? Yeah.
Right. It's just a starting point. You can adjust those reference points as you learn more. And it's helpful to think about the ideal vector and nadir vector, too.
Ooh, more fancy terms. What are those?
So the ideal vector is basically like the best possible outcome for each objective.
Okay.
And the nadir vector is like the worst possible outcome for each objective.
So it's like setting the upper and lower bounds for what you're willing to accept.
Exactly. And the algorithm uses those reference points to generate solutions that fall somewhere within that range. So it's not just randomly spitting out options.
It's using your preferences as a guide. I dig it. But I'm a very visual person. How do we actually see these solutions and these trade-offs?
That's a great question. And it brings us to the heart of what this research paper is all about.
The interactivized part.
You got it. It's all about combining interactive visualization with the optimization process. So instead of just looking at numbers...
Please, anything but spreadsheets.
No spreadsheets here. Imagine being able to see the solutions as points on a graph or as bars on a chart, where each axis represents one of your objectives.
Oh, that sounds way more engaging.
It is. And you can actually interact with these visuals, filter solutions, highlight specific trade-offs, really get a feel for the landscape of possibilities.
It's like turning those abstract numbers into a tangible, interactive experience, kind of like those choose-your-own-adventure books, where you get to make decisions and see the consequences unfold.
Exactly. It's about making the process more intuitive and engaging. And the paper actually lays out the key tasks and requirements for building such a system. Like, we need ways to easily compare different solutions, see how changing our preferences affects the results, understand the relationships between our objectives. It's a whole framework for making this interactivized approach work.
So we're not just randomly clicking buttons and hoping for the best. There's real structure and purpose to this interactive process. But I'm still curious, how do we actually build this visual system? What are the tools and techniques involved?
Well, that's where we'll pick up in the next part of our deep dive.
Oh, you're killing me with the cliffhangers. But I'm definitely hooked. Can't wait to see how this all comes together. All right, well, welcome back to the deep dive, everyone. Last time, we started exploring this idea of multi-objective optimization.
Where you're not just maximizing one thing, you're juggling a bunch of different goals.
Right, like planning that awesome vacation that's also affordable. We left off with kind of a cliffhanger, though.
Yeah, how do you actually build a visual system to help you make these tricky decisions?
Hit me with the tech. What's the secret sauce?
Get ready for some seriously cool tools. Remember how we talked about that interactivized approach from the research paper?
Yeah, where you're not just staring at spreadsheets all day. Give me the visual.
Exactly. They actually use some specific tools to make that happen. Think of it like building a custom control panel for your optimization mission.
Okay, I'm picturing like a high-tech dashboard with flashing lights and colorful graphs. Am I close?
You're getting warmer. So they start with this powerful Python framework called DSDO.
DSDO.
Yeah, it's specifically designed for multi-objective optimization algorithms.
Okay, so it's like the foundation of our system.
Exactly. And then they use an algorithm called Interactive RVEA. This guy is great at generating solutions based on those reference points we talked about.
Oh, right, like those ideal values you want for each objective.
You got it. So DSDO and Interactive RVEA are kind of like the engine and navigation system of our optimization vehicle.
Love the analogy.
Yeah.
But we still need a way to actually see where we're going right, like some kind of map or visual representation.
You are so on the right track. And for that, they use a system called CMV. It stands for Coordinated Multiple Views.
A CMV. Got it.
It's like having multiple windows open on your computer, each one showing you a different perspective on the same data.
So, like one window showing the actual values of each objective for various solutions, another one showing how those values relate to my preferences.
Exactly. You're getting it.
And maybe even a window that lets me play around with the decision variables themselves.
Now you're talking like a true optimization pro. It's like having a map, a compass, and a telescope all working together to help us explore this landscape of possibilities.
So what does the actual map look like in this scenario? What kind of visuals are we talking about?
Okay, so the core of their system is this super cool visualization technique called parallel coordinates. Have you ever seen a music equalizer?
Yeah, like those rows of sliders that control different frequencies.
You got it. It's kind of like that. In parallel coordinates, each slider represents one of your objectives, like cost or enjoyment level for our vacation example.
Okay, I'm visualizing it.
And then each possible solution is represented by a line connecting those sliders, showing how it scores on each objective.
So wait, if I see a line that's really low on the cost slider, but high on the adventure slider.
That means it's an affordable trip with lots of exciting activities.
You read my mind. This is starting to click.
It's a super intuitive way to compare different solutions and see the trade-offs. You can quickly spot those trips that are budget-friendly, but maybe a little light on relaxation, or, the ones that offer a good balance of everything, but at a higher price point.
So it's like a visual representation of all those compromises we have to make.
Exactly. And here's the best part. It's interactive. You can click on different lines to get more details, filter solutions based on certain criteria. You can even adjust your reference points and see how it affects the options displayed.
So I'm not just passively looking at a static chart. I can actually play around with it and see how my choices affect the outcome.
Exactly. And I think that's what makes this approach so powerful. It's engaging, it's intuitive, and it really puts you in the driver's seat.
This is so much cooler than staring at a spreadsheet. It's like I'm actually exploring this multi-dimensional world of possibility.
I know, right? It's a total game changer.
Speaking of games, you mentioned that river pollution problem earlier. Can we use that as a concrete example to see how this all works in action?
Absolutely. So picture this. You're a decision maker, and you're tasked with finding the best way to manage pollution levels in a river.
Okay, high stakes.
You've got a fishery upstream and a city downstream, both contributing to the pollution problem.
Right. Classic environmental dilemma.
And you have these treatment plants that can help remove pollutants.
But those probably come with their own costs, right?
Exactly. Running those plants costs money. And there's also the potential for disruptions to the plant's optimal operating conditions.
So right away, we've got multiple conflicting objectives. We want to minimize pollution, but we also have to consider the economic and operational costs. Sounds like a real-world mess.
It is. And in the study, the decision maker was able to use this interactivized approach to explore different strategies, visualize the trade-offs, and ultimately arrive at a pretty awesome solution.
Tell me they saved the river.
They did. Well, they found a solution that really balanced environmental protection with economic considerations and operational efficiency. They started by setting reference points that prioritized water quality. Kind of like saying, show me what's possible if we really focus on cleaning up this river.
So it's like setting the bar high and then seeing what solutions can reach it.
You got it. And as they explored the different solutions, they realized they could actually achieve significant improvements in the fisheries' return on investment without sacrificing too much on water quality. So they adjusted their reference points to reflect that new understanding.
It's like they were learning as they went, realizing they didn't have to choose between the environment and the economy.
Exactly. They found a way to make both sides happy.
So did they find, like, the perfect solution?
Well, remember what we talked about earlier? With multi-objective optimization, there isn't always one single perfect answer.
Right. More like finding the best fit for your specific needs and priorities.
You nailed it. It's about finding a solution that you feel confident about, one that takes all the different factors into account. And in this case, the decision maker was able to use those interactive visualizations to really understand the problem, explore the possibilities, and ultimately arrive at a solution they felt good about.
Way better than just crunching numbers in a spreadsheet, right?
Absolutely. And the researchers actually compared this interactivized approach to a more traditional way of using multi-objective optimization, where you're basically just typing in numbers and looking at static charts. And what they found was pretty amazing. The people who used the interactivized system, they felt way more confident in their decisions. They had a much better grasp of the trade-offs involved. And get this, they were even able to come up with more creative solutions.
More creative solutions? How is that even possible?
Because they had the tools to explore a wider range of possibilities. They weren't limited by just a few predetermined options. They could really play around with the data and see what emerged.
It's like they were empowered to think outside the box, thanks to this visual interactive system.
Exactly. And it's not just about making better decisions. It's about making the decision-making process itself more enjoyable, more engaging, and ultimately more empowering.
So even though we've been talking about this river pollution example, the same principles could apply to all sorts of decisions, right?
Well, absolutely. Think about something like designing a new product. You might have objectives related to cost, performance, durability, aesthetics, sustainability.
Right. So many factors to consider.
Using this interactivized approach, you could explore different design features, materials, manufacturing processes. You could visually compare how each option scores on each objective.
And find that sweet spot that balances all those competing priorities.
Exactly. Or imagine you're planning a big project with your team. You could use this approach to map out different tasks, timelines, resource allocations, make sure everyone's on the same page and working towards the same goals.
It's like having a superpower for decision making. I love it. But are there any limitations to this approach? Like, what if the problem gets really complex or involves a ton of data?
That's a great question. Of course, no approach is perfect. One potential challenge is scalability. As the number of objectives, solutions, and data points grows, the visualizations can definitely become more complex and harder to manage.
So it's like our map is getting so detailed that it's hard to see the forest for the trees.
Yeah, exactly. But the researchers actually addressed this by using some clever techniques, like clustering, which basically groups similar solutions together, reducing the visual clutter. They also emphasized the importance of a user-friendly interface, one that allows people to customize the display based on their needs and cognitive capacity.
So it's like having a zoom function on our optimization map, allowing us to focus on the details that are most important to us.
You got it. It's all about finding that balance between presenting enough information to make an informed decision, but also avoiding information overload. You don't want people to feel overwhelmed or lost in the data.
Makes sense. We've talked a lot about the technical side of things, the tool, the visualizations, the algorithms. But what about the human element? How does this approach actually change the way people make decisions? Yeah, it's easy to get lost in the weeds when you're talking about algorithms and visualizations.
For sure. But at the end of the day, it's all about helping people make better decisions, right?
Absolutely. So how does this interactivized approach actually change the game for the average person?
Well, think about it this way. Imagine trying to explain a complex optimization problem to someone using only like a Jupyter notebook, just filled with code and static charts. Not exactly the most exciting way to communicate those trade-offs and insights.
Yeah, I can practically feel my eyes glazing over just thinking about it.
Yeah.
But with this interactivized approach, it's like you're inviting people into the process, letting them actually explore the data, experiment with different preferences.
Exactly. And they get to see the results in a way that makes sense to them. You're turning data into like a dialogue, not just a lecture.
It's like the difference between being told what to do and being part of the decision-making process.
Exactly. And that sense of agency and ownership can make all the difference, It helps people feel more confident and invested in the outcome.
And that brings us back to the heart of this whole deep dive, right? This idea of interactivized optimization.
Yeah. It's about recognizing that human judgment and intuition are still essential parts of the process.
Right. We're not just robots blindly following algorithms.
Exactly. And visualization can be such a powerful tool for bridging that gap between the abstract world of data and the messy reality of human decision-making.
It's not just about finding like the mathematically optimal solution. It's about finding the solution that feels right for you based on your values, your priorities, your understanding of the problem.
And what's interesting? The researchers actually found that people who use this interactivized system, they reported feeling more confident in their decisions.
Well, that makes sense. If you're more involved in the process, you're going to feel more ownership over the outcome.
Right. They also had a better grasp of the trade-offs involved, and they were even able to come up with more creative solutions.
More creative solutions. That's awesome. How does that happen?
Because they had the tools to explore a wider range of possibilities. They weren't limited to just, a few predetermined options. They could actually play around with the data, see what emerged, and come up with new and innovative ideas.
So it's not just about making better decisions. It's about making the decision-making process itself more enjoyable and empowering.
Exactly. And the cool thing is, this approach can be applied to so many different areas. We've been talking about river pollution and product design.
Right, but it's not limited to just those fields.
Not at all. Think about personal finance, for example. You could use this to figure out the best way to invest your money based on your risk tolerance and your financial goals.
Or in healthcare, doctors could use it to tailor treatment plans to individual patient needs.
Yeah, the possibilities are pretty much endless.
Wow, we've covered a lot of ground today. From the technical nitty-gritty of algorithms and visualizations
to the really profound impact this approach can have on the way we think about and make decisions.
It's been quite a journey.
It has. And hopefully our listeners are feeling inspired to take a more interactive approach to their own decision-making challenges.
I know I am. As you're wrestling with those tough choices today, whether it's planning a project, making a financial decision, or even just choosing what to have for dinner.
Right. It can apply to anything.
Remember the power of visualization, the importance of understanding those trade-offs, and the value of bringing your own unique perspective to the table.
You don't have to settle for the first solution you come across. Explore those possibilities.
Keep diving deep, everyone, and keep those brains engaged.